This educational video is to promoting active learning of powder diffraction. The outcomes for this topic: 1. To define crystallite size. 2. Is to explain the properties of powder. And 3. Is to determine the crystallite size.
What is powder diffraction? Powder diffraction is a non-destructive method and a scientific technique using X-ray for analyzing the atomic and molecular structure of materials.
According to Bragg's law, the crystallite needs to be orientated correctly with respect to the X-ray beam in order to diffract. In powder diffraction, only a small fraction of the crystals are correctly oriented to diffract. The incident beam need to rotate in order to detect all orientation of powder samples. When these planes are correctly oriented with respect to the X-ray beam to diffract, the atoms scattering in phase and producing an intense diffracted ray. The differences between crystalline and particle is: a crystallite is a single crystal in powder form. Crystallite is a small crystal. It could be made of many atoms or molecules. A particle composed of two or more individual of crystallites. These are separated by domain walls, disturbing the coherent scattering of the X-rays.
There are three types of crystal: crystalline, polycrystalline, and amorphous. Crystalline materials will have the highest intensity or peak, while amorphous materials like polymer will have the lowest intensity.
How to determine crystalline size? By using XRD data, we have to determine the FWHM by selected the best or high diffraction peak. After that, use the shearer length formula to get the crystalline size.
This part will show you how to determine full at half maximum. So, from the graph, XRD theta, let's state the best or higher peak. The peak is shown in the figure. This is the maximum intensity of the peak. This is FWHM. This width is half of the maximum intensity of the graph, that's why we call it FWHM. The question is how we can get the value. Let's say this is our graph. From the line FWHM, we take the value of 2 theta at the x-axis, which is 2 value. Let's say we name these 2 value or x1 and x2. So, just subtract x2 minus x1 equal to value of FWHM.